Hey everyone, my name is Tony Frum. I'm one of the sales engineers here at McAfee, and today I'm going to be going over a product demonstration in a simulation that we call the Threat Defense Lifecycle. What we're going to be covering today is really some of the newer technologies that are added onto our endpoint security platform. So the platform has a multitude of different technologies, but what we're going to be focusing on today is what we call adaptive threat protection. This is a module you can add on to endpoint security that brings with it some next generation technologies for protecting your endpoints. That would include, among other things, machine learning. So there's a technology called Real Protect that includes a pre-execution machine learning capability, and then also there's a post-execution analysis where we can do analytics on behaviors. And then there's also another technology called dynamic application containment, where if we allow a process to go ahead and execute, we can start blocking certain behaviors if that process does not meet a certain trust level. So we're going to dive right into a live demonstration of these technologies so you can see what they look like in action. So this is our victim machine, and you can see here it's running McAfee Endpoint Security 10.5. And we have two modules installed. The first is threat prevention. Threat prevention is basic protection with traditional AV scanning and exploit prevention capabilities, including intrusion prevention. And then the second module is adaptive threat protection. That's where a lot of the newer technologies, including Real Protect, which is machine learning, and the dynamic application containment reside. So what we've done is we've cloned the PuTTY website so that if someone in this environment goes to download PuTTY, they're going to actually be pulling down an infected copy of PuTTY. So it's a file that will actually kick off a legitimate copy of PuTTY, and then in the background will infect the machine and have it connect to a command and control center for a botnet. So it's a botnet infection embedded into PuTTY. So what we're going to do is just open a browser here, and we're going to search for download PuTTY. And then we're going to go to the download site here and just go ahead and download this infected file. You'll see here that we got a detection on this from traditional AV scanning. So if we come in here and look at our downloads directory, you'll see the file's been removed. And if we look at endpoint security and look at the event log, we have a threat prevention on-access scan detection. So if we blow this up here, you can see that that we had a detection from traditional AV scanning. So here's the file that was detected. So I think everybody knows that traditional AV is something that can be beaten. So rather than me going through the steps of trying to figure out how to do that, we're just going to assume that that this was in fact a 0-day that got around AV scanning, and we're just going to go ahead and turn off AV in the threat prevention module. So you see here I'm disabling on-access scanning entirely, so AV detection is going to be completely disabled. Okay, so now we're going to go back to the website and we will try to download this file again. And this time we're able to download and save it successfully. So now we're just going to go ahead and execute it. So you'll see I got an error message, and if we go back to our event log, you'll see here that we have a detection here, and it says Real Protect Client is the detection type. So this is the pre-execution machine learning scan. So this is machine learning technology built into the adaptive threat protection module that happens before execution is allowed. And this is not signature based. This is based on mathematical algorithms to determine what we think the likelihood is that something is malicious. So this triggered a scan, so we're just going to go ahead and turn this off and give it another shot. So we're going to go into the settings for the adaptive threat protection module, and we will turn off the client-based scanning, which is the pre-execution piece. So the file was removed. and we're going to have to download it again. So we're going to come over here, click the download once again, and we're going to try to execute this again. So you'll see that we actually got a PuTTY window this time, so it did start to execute. But you'll see now the file's been removed, and if we go back to our event log and refresh it, you'll see that now we have a detection from RealProtect Cloud. So what this is a post-execution analysis. So if we allow something to start running, then if we don't trust it, we'll start monitoring the behavior of that process and doing analytics on it in the cloud. And if we see a combination of behaviors that tells us that something is malicious, then the endpoint will kill the process and then clean up after it. So that's what occurred here. And if we go back into my downloads folder, you'll see the file was removed yet again. So now we're going to go back here and we're going to disable that functionality as well. So we got past the pre-execution scan, now we want to get past the post-execution analysis. Okay, so we're going to download this thing again. And execute it once more. And you'll see that we have another detection that's coming up. So if we go into our log here, you'll see that we had a clean action on this process, and the threat type was a dynamic application containment detection. And if we review our log here, you'll see that we actually had a whole lot of events that came up. So when we allowed this thing to run, we were no longer doing the post-execution analysis with RealProtect, but what we were doing was running this process inside of containment. And so what we're doing is we're starting to block certain behaviors that we would not want an untrusted process to do, and then monitoring others. And if we see a certain number of behaviors occur that that indicate that this thing is malicious, then we're going to actually kill it. So let's go back and review some of the things that we see here on the dynamic application containment. So you'll see that some of these are blocked and some of these are simply monitored and show that they would have been blocked. So we first blocked it trying to establish persistence on the machine. So it was modifying a startup registry location. And then here, this is the actual malware itself that's being dropped, and we blocked it from marking that as a hidden file. And then you can see here that it was actually trying to disable the registry tools. So we blocked that as something where it's disabling critical operating system executables. So once we had enough activities that we considered to be either risky or suspicious from this untrusted process, we finally just killed the process because it had exhibited enough negative behaviors that we just decided that it needed to be killed. So this time we did not actually remove the process, so we can fire it off again. We're going to go ahead and disable the application containment. So now we've been through AV scanning, the pre-execution machine learning, the post-execution analysis in the cloud, and then the application containment functionality. Now we have pretty much all of our protections disabled on the endpoint. So if we kick this thing off again, we should actually get a successful connection into our control center. So PuTTY's open, and in the background we now have a connection on my botnet. So this is the control server. Here is my client machine, and now this machine is completely owned by the infection. So I can come in here and, for example, look into the file system and drill in, and we'll find my PuTTY file in downloads here. So there's the infection that we have running. And so we've been through the protection phase. Now what are we going to do to detect this infected endpoint and then remediate it? So we're going to jump into ePolicy Orchestrator, and we're going to go into the Active Response workspace. So Active Response is our EDR solution, our endpoint detection and response. So what this is going to do is give us a list of all of the processes that have run in the last few hours that McAfee either does not know about or does not trust. And they're going to be classified based on their behaviors. So if we do a quick search, you can see that PuTTY here is showing up as suspicious. And if we click on this PuTTY executable, then I'm going to get a list of the machines that are running it. So this is my victim machine here. So if we click on the victim machine name and scroll down, we're going to get a timeline view of everything this process has done on the endpoint. So we're going to blow this up, and we're going to have multiple executions here. So if we zoom in, this is our first execution where it was caught by RealProtect static, so it was terminated pretty much immediately. This is the execution where it was blocked by RealProtect Cloud. So it started running, and we kill it based on the analytics of its behavior. And then here is where we blocked, or we kill the process based on the dynamic application containment. And we're seeing all the different behaviors. You'll notice it's actually calling out the ones that have been blocked. So application containment was running, and you'll see here is where it tried to disable the registry tools, and you can see that that was actually a prevented action. So we're showing, not only the behaviors that occurred, but which ones we were actually blocking. So if we scoot over farther to the right, you'll notice that there's an arrow on the right side here that indicates that this process is still going. So if we zoom in, we'll see the same behaviors, but none of these are blocked now because all of our protections are turned off. So if we zoom in all the way here, here's the registry tools being disabled, but this time it actually happened and we did not block it. So we can review some of these behaviors. You'll see that we can see every process operation, every file operation, every registry operation, and then network connections as well. So since this is a botnet infection, one of the things that might be a key for us is the network connection. So if we were to just uncheck these three options and look just at the network connections that were established, then we can click on this and see here's the actual IP address of my command and control center. So if we click on this link, I can then search across the entire environment and say, hey, who else has talked to this IP address and what process opened that connection, and get a not only a snapshot point in time, but an actual historical result on what other processes and machines have made connections to that IP address. So at this point, if I'm convinced that this is in fact a malicious threat, then I can back out of this and say, you know what, on this machine here, we need to go ahead and take action. So you'll see here that I've got the connection open in my command and control. And if I come in here and say that I want to stop and remove that threat and confirm it, then you'll see the connection disappears from the command and control center. So we killed the threat on the endpoint. So what we've covered so far is the protections that are built into the endpoint itself. So now let's take a look at kind of an offline file analysis capability we have with what we call Threat Intelligence Exchange and Advanced Threat Defense. So Advanced Threat Defense is a sandboxing appliance, and in conjunction with everything that we just showed, you can have an endpoint submit any unknown files to Advanced Threat Defense for kind of an offline scanning. So in parallel with all the protections that we were just looking at, we can have that sandboxing solution chewing on that file, and then as soon as we get a conviction from the sandbox, then everyone in the environment gets updated. So we're going to go back into Adaptive Threat Protection. You can see that everything's still turned off, but we're going to enable sending samples of unknown files to to the sandbox. So we're going to go ahead and apply that. And you can see we've removed the file, so we're going to download this again. And now we're going to go ahead and execute this again. And if we jump back to the command and control, you'll see that I now have actually two connections coming into it. The first one, this is the victim machine running the thread again, but this is the sandbox instance. So the sandbox is actually analyzing the file. So if we go into Advanced Threat Defense and look at our status, you can see that putty.exe is being analyzed right now, and that's why we have a connection here. So it's running in a live sandbox environment. So you'll see this connection disappear when the analysis is done on the sandbox side, but there's a couple other things that Advanced Threat Defense is doing outside of just sandboxing. So there's a static analysis where it's basically picking apart the code, looking for hidden payloads that maybe didn't execute during the sandboxing phase. So it's going to take about 15 seconds to 30 seconds for it to finish up that analysis, and then when that's done, you'll see this connection disappear. So the endpoint has been updated to that conviction. So if we refresh our page, you'll see the analysis is done. I can look at the report and see that this was convicted with a very high threat rating. So at this point, without any protections turned on the endpoint, just the simple fact that we were able to submit for an offline analysis on the sandbox made it to where the endpoint was updated in real time to that threat and killed it without really any protections of its own. In addition to that, if we go back to my victim machine here and try to download the file again, you'll see I got a block page from my web gateway. So this is not something that's strictly shared between the endpoints. This is something that's shared with the perimeter devices as well. So this would include our McAfee security for Microsoft Exchange. So if this were to come in through an email, that product would block that attachment. This includes obviously the web gateways, but also our network intrusion prevention sensors. So pretty much across the board, an automatic reaction to this conviction from the Advanced Threat Defense appliance. There is also a cloud offering called Cloud Threat Defense if you don't want to run something on premise for the sandbox. So there's one more piece that we haven't covered yet. So if we were to have a botnet infection like this that was server-side polymorphic, meaning every time you download it, the file's slightly different, you have a new hash, then we would have to go through this entire process again. So rather than having to do that, it would make more sense for us to proactively try to find something to look for, a behavior that we can block. So if we go back to our report from Advanced Threat Defense, we can see every file operation, every registry operation, every process operation that was exhibited by this threat. Of course, we had the same thing in the active response workspace as well. So we would probably want to come in here and say, okay, what about this is unique? Where's a behavior that we can look for that would be unique to this threat so that we can block anything like this in the future? And one thing we might look for is the connection to the IP address. So we have the IP for the botnet, so we know what to look for. So what we're going to do is we're going to create what's called a trigger. So I'm going to go into active response, and we're going to create a trigger to tell our endpoints to start persistently monitoring for a certain behavior. So we're going to create a new trigger here. We're going to call it block connections to fake putty command and control. So we're going to enable this, and we can create a trigger based on a file being created or modified or deleted, a process starting, and a network connection being opened, or a registry value being read or modified or created. So we're going to create a trigger based on a network connection being opened where the destination IP address equals the IP that we pulled from the report. So I'm going to type that in here. Now, if I want, I can just leave it like this, and anytime this occurs, I'm going to get a threat event within EPO. And you can create any kind of automation off of that. You could tag the machine, you could move it somewhere in the system tree, kick off an on-demand scan task, simply email an administrator, any combination thereof. But if you want it to react instantly, then we can come in here and say, okay, let's just execute a reaction when this occurs. And when it occurs, I want to kill the process that opens that connection, and then the process ID we're going to go ahead and pass to that reaction. So anytime we see a connection to this IP address, we kill that process. So this will allow us to be more proactive and less reactive in the future. So we're going to go ahead and save that out. And because my entire environment is now wise to that particular file that we've been using so far, I'm going to have to generate a new one. So we're going to come back in here to my command and control center, and we're going to generate a new stub file to test with. So I'm going to call it putty again, and we'll overwrite our existing file. And now I'm going to copy that onto my web server, and then we're going to jump back to my victim machine. So we're going to again search for download putty. Go to the download site, download the file, and this time I will be able to download it because it is a new file hash. So the conviction from the sandbox is not protecting me. Now, if I open a connection or execute this file, and we go back to my command and control center, I get a connection, but only just for a second. So the connection closed because the process was killed as soon as the connection was opened. So if we go back to our victim machine and send all the events, and then go back into EPO and take a look at this, I'm going to find my machine here in the system tree. And if we look at the threat events, you'll see here that there was a network flow trigger event. And if we drill into that, this is the name of the actual malicious file that opened the connection. And in fact, if we go back to my victim machine, I can even put in the IP address of the machine into this totally legitimate copy of putty, and you'll see that as soon as I click open, the process is killed. So across the board, the entire environment is killing any new process, whether it's legitimate or otherwise, as soon as it exhibits that behavior. So I hope that this has been helpful. If you have any questions, reach out to your sales account manager, and we can schedule a call to answer those questions or do any additional demonstrations. Thanks for your time.